Oops, time to over my 15 minutes. All right, so I think I had said what I needed to say for 27 and 28. Just as a reminder, we compared them. 27 is Cu2O, 28 is just CuO. And again, that is the two differences here, and this is why it's important to have Roman numerals to tell your reader about what is the charge of a transition metal, because otherwise you wouldn't know. So the last two examples that I wanted to have us take a look at was 33 and 34, going from formula back to nomenclature. So in ionic with a set charge, which is what you were looking at primarily yesterday, because alkali metals, alkali earth metals, aluminum, silver, zinc, and your only polyatomic cation, NH4+, have a set charge, you don't have to indicate anything in your nomenclature. So that's why, sodium chloride is just sodium chloride. Now, with these examples, you must indicate your charge of your metal in Roman numerals. So we're going to use the sort of information that we're given in our formula to deduce it. So you'll notice my work on the image that I'll attach here. But for 33, we are comparing this to 34 because we have different ratios, different numbers of atoms. In 33, we have copper. We have 2 atoms of copper. And we have sulfur. We have 1 atom of sulfur. Versus in 34, FeO, we have 1 atom of iron and 1 atom of oxygen. So the first thing I do is I tell myself about what I know. We're not 100% sure immediately about the charge of copper or iron because they're transition metals, but our context clues are the anions, the sulfur and the oxygen. So sulfur has a set 2- charge. It has to be 2-, can't be anything else. Same with oxygen, and they are in the same group. But so oxygen has a set 2- charge. Again, can't be anything else. It's 2 away from a completed energy level or a complete octet. So when it forms an ionic compound, it will always have that set charge. Again, it's only the metals the transition metals whose charge will change. So if I know in 33 Cu2S that sulfur is 2-, it must be that positive 2 is sort of the sum of your 2 atoms of copper. So I like to say, okay, that cation side is the equal but opposite. So if the anion side is 2- from 1 atom of sulfur, and the copper side, it must be a 2+. Well, I have 2 atoms that create that 2+. So it must be that each atom of copper is a +1. So I need to report that. So we're going to say copper, parentheses, Roman numeral 1 for the positive 1 charge on copper, end parentheses, and then we're going to name our anion. It's sulfur, but it's the elemental form. It's our second element. So we drop the ending and gain IDE. So it's copper 1 sulfide. Compare that to 34, FeO. We have oxygen. It also has a set 2- charge. We have iron, but there's only 1 atom of iron. So again, there's 1 atom of oxygen, so we have 2- on our anion side, 1 atom of iron. So the positive 2 on our cation side must be entirely from that 1 atom of iron. So it must be Fe2+. So it must be that our nomenclature will read iron, parentheses, Roman numeral 2, end parentheses, oxide. And again, we're changing that oxygen to an oxide. All right, those are the couple of examples. Let me know if you need a little bit more. I hope that helped.